Okay, today we are looking at solving rational equations. Okay, so in your notes, what is this, about page 4-ish, something like that? Yeah, I know, but you can count. It's about the 4th page back, I think. You see it right there, solving rational equations. Yes. Well, we'll talk about that. We'll talk about that. If you're really careful, you can maybe get by without it, but we'll talk more. So there are two different methods, and they go with the two different. One is if left side of the then this process becomes cross multiply to equation you get when you cross multiply. Okay, so if you have a proportion, so what do we mean by that? Well, you guys know what cross multiplying means. I'm just going to find that cross product. Times 8. And so we're going to get simple quadratic equation that we can just solve. How would we solve that one? Do we need to use quadratic formula, or can we factor it? We can factor it. Yeah, what are the magic numbers? M plus 6 times m minus 5 equals 0. So my solutions, but if I apply the zero product property, Karsten, what's that solution going to be for that factor? Zero product property, right? Because now I've got it factored. I've got a product of factors is equal to 0. So a product of factors equals 0 whenever the individual factors are 0. So what value of m is going to make that factor 0? Negative 6. So there's one solution. M equals negative 6, or there's one. The other possibility would be this guy. What would that be? Positive 5. Okay, but we got to check our solutions, right? Now we'll talk about that. So we got to check the solutions. We plug them back into the original equation, and let's just see what happens. If I plug in m equals negative 6, what do I get? Well, I get negative 6 plus 3 is negative 3 over 3, which is just negative 1, right? How about the other side? I get 8 over negative 6 minus 2 is negative 8. Well, that's negative 1 equals negative 1, which is true. So this one checks, right? How about the other one? If I plug in m equals 5, what do I get? Well, I'm going to get the left expression, the left fraction is going to become 5 plus 3, that's 8 over 3, equals 8 over 5 minus 2, that's 8 over 3. So it checks out. They both check out. Okay, I could have predicted that though. The one thing we didn't do in this problem that we've done in the past is we didn't keep a tally of the values of, not x, of m that we have to exclude. Well, what are they? If I look at the original function up here, are there any values of m I have to exclude? -3 is okay because that's a 0 in the top. That's okay. 2 though, 2 would be a problem, wouldn't it? Because that would cause us to have a 0 in the bottom of a fraction, and we can't divide by 0. So this guy right here tells us that m cannot equal 2. So any solution we get that's not an excluded value is going to be fine. Our solutions, neither one of those was 2, so they're good, right? Does that make sense? So when it says always remember to check your solutions, yeah, that's one thing you could do. The other thing you could do is just keep track of all the excluded values and just see if any excluded values correspond to solutions. Because if they do, we have to cross out that solution. Okay? Either way. All right, so now when we move on to the next part is using a least common denominator. When we don't have proportions, when we have more than one fraction on at least one side of the equation, then we're going to do what we did in the past. We always did in the past if we were solving simple equations. We always clear the fractions. We multiplied through by the least common denominator of all the fractions, including fractions, right? We've done that many times. Agreed? Do we need to see an example? Do everyone know what I'm talking about, or do I need to put an example up to remind you? Anybody like to see an example of that real quick? Okay, so let's take a really quick one. Like, what if we did something like, what if I had x, let's say we had x over 3 minus 1/5 equals 3x over 2. Okay, what could I do to that? How would I clear the fractions? What would I have to multiply through by here? Not 5. It's got to be the least common denominator, the smallest number that they all divide into. What would it be? No, not that divides into them, that they divide into. So what it really is the least common multiple. Like what's it? 15, but does 2 go into 15? 5 doesn't go into 18. 30 would be it, wouldn't it? 30 would be it. 30 is the smallest number that they all go into. Now, how did we get 30? Well, really all we did here, these are already factored, aren't they? So we just found the smallest number that includes each of the factors that shows up in the denominators, which is 30. If I distribute that through, I will clear all the fractions and this becomes simple, right? Okay. We're going to do the same thing for problems that look like this. Let's just pick one as an example that look like that. We want to multiply through by the least common denominator that's going to cancel all of the denominators when I distribute it. Okay. Just like this one does. If I distribute the 30, what happens? I get 30 over 3, right? 30x over 3 minus 30 over 5 equals 90x over 2. Well, look, I can simplify. I can reduce each of those fractions and cross the denominators out. I get 10x minus 6 equals 45x. And now that's easy, right? Now I can just solve that equation. So the same principle is going to apply for us when we have variables in the denominator, like we do with rational equations. Okay, so what's our strategy here then? Well, to find the least common denominator of two fractions, what is that? So that's going to be, least common denominator is going to be the product of all of the different factors that show up in the denominators. That's it. Okay. We got to pay attention to one thing though. With each factor that is raised, with each factor in our least common denominator has to be raised to the has to be raised to the greatest power that shows up in any one of the denominators. And we'll see an example like that pretty quick, so that'll make sense. So the easiest way to do this, if I want to find the least common denominator of these two fractions, is just to make a list, and we'll just include in our list, it's really, instead of a list, it's more of a product. I'm going to multiply all of the factors that show up. Well, let's start with the first fraction. What's the only factor in the first fraction? No, in the denominator. X. Okay, good. So then we've got, one thing we get is we get an X. Okay. What's the only factor that shows up in the second denominator? X minus 7. And that's a new one. That didn't show up in the first one, right? So we've got to multiply by that as well. So our least common denominator would just be X times X minus 7. That's it, right? It's going to be the shortest list of the product of factors that includes each factor from each denominator. Okay, let's do another one. Okay, this one's a little bit tougher because in the first one, the denominators were already prime factors. In this one, they're not. So what do you think I have to do to this thing before I can start? I've got to factor them, don't I? Right, I've got to factor each one of these denominators. Okay, so what about the first one? The first one here, I end up with 9 divided by, 9's on the top. The tops we can leave alone, right? It's just the denominators need to be factored though. How does 5x plus 15 factor? 5 times quantity x plus 3. Okay, good. And my second fraction, in the top we've got an 8. How does the bottom factor? Times x minus 2. Okay, so then now we can build our least common denominator. Least common denominator, let's start with our first fraction. Tell me a factor I have to include. 5. There's a factor, right? We got to include 5. So we get 5 times x plus 3. Each of those factors has to be included. Now, what about the second fraction? 7 times x minus 2. Okay, so all those have to be included. So then we could, what can we do here? Well, at least we could multiply the numbers together, right? So we just get 35 times x plus 3 times x minus 2. That's our least common denominator. That's the answer. Well, that's, yeah, for this problem, we're just trying to find what is the least common denominator. We're going to practice this a little bit first, and then we'll use this to solve an equation. First, we just want to get used to doing this. Make sure we all understand this and feel good about it. Okay, how about this one? Now we got 3 fractions. So what about the first guy here? X over, how does the bottom factor there? Okay, x minus 4, x plus 4. Good. Okay, next one. Well, that one's done, isn't it? Bottom's already prime. Okay, now this last one we got to be a little careful on. Okay, look at this last guy. So if we look in the denominator, look at that denominator. It's not written as a proper polynomial, right? It's not written in standard form, is it? So what we want to do is we want to rewrite that denominator in standard form where we're going to go from highest power of x to lowest power of x. So we would write it as negative 5x plus 20, okay? Now, what could we factor out of that? -5. Good. We're always going to, if the leading coefficient is negative, we factor out a negative number, right? So we're going to break that one down to 7 over -5 times what? X minus 4. Okay? So now we've got each of those denominators factored. Now we can make our list of the, of the products that form our least common denominator. Okay, so what do we need first? X minus 4, and there it is. So there's an X minus 4. What's next? X plus 4. What's next? X. Okay, I'm going to go ahead and we'll just put it out here for now. So we get X. What's next? -5. What's next? Okay, but we already have that on the list, don't we? Uh, it doesn't get squared because it's not squared in either of these denominators. So we don't even need to. The thing is, it already is included right there, so we don't have to add it again. It's already on our list. Okay, make sense? So then this is our least common denominator. What could we do here? There's one little thing we could do to make this look a little bit better. What could we put out front? -5x, how about? Right. So we get -5x times x minus 4 times x plus 4. There's our least common denominator. I'm not sure, but you should. You should always, kind of the rule is in math, when we're writing out a product of stuff, we always put constants out front. So like numbers would go first. And if there's a monomial, we put the monomial first and the binomials and trinomials next. Okay? All right, let's try one more of these. How about this guy? Okay, same thing. We gotta rewrite this. So how about this first one? What can I factor out there? Okay, so I take out a 4, and that one, and by the way, notice here that these are denominators of fractions. We're not writing them as fractions. They're just giving us a list of the denominators to work with. So we could take a 4 out of that, and we're left with what, x minus 1? Okay, what about my next denominator? That guy. X squared plus 2x minus 3. How does that factor? So what did you say, plus 3 and minus 1? Okay. And then our last denominator, this guy, is what? Say it again. X plus 3 times x plus 3. Okay, good. Now, if I want to, I could even just call that x plus 3 squared, right? Okay, now that means, look, we finally have one of our denominators has a factor that's being squared. Okay, so we got to pay attention to that when we make our least common denominator product. So let's do that. Okay, what goes in there first? X minus, well, we'll hold it. Even before that, 4. Okay, good. So we get 4 times x minus 1. Okay, what's next? X plus 3. Okay. Oh, what about that one? It's already there, right? We already have an x minus 1 to the first power, don't we? Okay, so that guy can stay there, okay? How about this one? X plus 3 to the first power, already there, right? Okay, so we have one of those, one of those guys is already there. But there's another one right? So what's that mean? If there's another one, that means we have to include that other one here as well, right? Okay, probably the easiest way to do that would just be to say, well, x plus 3 times x plus 3, that means that we're going to get a squared there. Okay, make sense? We knew that had to happen though, because let's go back to our notes on that first page right here. What's it tell us? The least common denominator of two fractions is the product of all the different factors from each denominator, with each factor raised to the greatest power that occurs in any denominator, right? So in this example, look, we have an x plus 3 squared in one of our denominators, so that x plus 3 has to be squared, right? Because in our least common denominator, it's got to show up to the greatest power of that factor that shows up in any denominator, right? Make sense? And again, one of those x plus 3's was already accounted for, but the second one means we have to square it. Okay? So and let's maybe make a little, so because that's there, right? So what's our LCD? That's it. We can't do anything else with it. That's it, right? It's already simplified. Make sense? Okay. So now let's apply this to a problem. Okay, so what about this one? Now we've got a rational equation, and the way we're going to deal with this is method 2 because it's not a proportion. So we're going to have to distribute through the entire equation the LCD. Okay. First, though, we got to get the LCD. What's our first step in finding the LCD? Factor the denominators. Yeah. So that one right there, prime already, isn't it? Right? So we're good with the first one. Second one, let's make that a fraction. If I have an integer there or something that doesn't have a denominator, just divide it by 1 so it looks like a fraction. Okay. And then what about the third one? How's that factor? Say it again. Difference of squares. You're right. P squared minus 2 squared. So what is that? Like P minus 2 times P plus 2? Okay. So let's make our list then. Our LCD, what's the first thing on the list? P minus 2. Okay. Does this guy, well, 1 doesn't contribute anything. How about over here? I've got a P minus 2 to the first power that's already taken care of. Anything else? P plus 2. So there's our LCD, right? Everybody see that? Okay, now we clear fractions. What did we always do in the past when we cleared fractions? We just multiplied the entire equation. We just distributed the LCD through, right? Let's write it as a fraction divided by 1, though. So it just reminds us that this is only being distributed, the least common denominator is only being distributed to the numerators, right? 1 is being distributed to the denominators, which doesn't change any of those. Okay, so then what happens to our first equation, or our first fraction, sorry. The first fraction, we already had a p in the numerator, but now we're going to also multiply that times p minus 2 times p plus 2, because those got distributed to the first fraction, right? The second one, so we go plus, and then the bottom is just still a p minus 2, right? Second one, we had a 2 on the top, so we're going to distribute to that second numerator p minus 2 times p plus 2, right? 1 is still on the bottom. And the third one, we end up with 8 times our LCD. So 8 times that product, p minus 2 times p plus 2. Okay? So now is a good time for us, I mean, either one of these steps, maybe let's keep track of the values. Oops, didn't want to do that. Darn it. Let's keep track of the values of p that need to be excluded. What can p not equal? 2 or negative 2, right? Okay. All right, so now we're in the process of clearing fractions, right? We distributed the LCD through. How come? What happens here that's good? We cancel a bunch of stuff. What happens, what cancels in our first fraction? Yeah, look at that. The p minus 2's cancel. Second fraction, nothing cancels, right? Third one, both factors cancel, right? So a lot of stuff goes away. Okay, well then that's good. All the denominators got canceled. What's left? In the first fraction, the only thing that's left behind is just p times p plus 2. Whoops, right? So p times p plus 2. In the second one, everything stays there, right? And in the third one, the only thing left is 8. Everything else canceled. But look what we did. Now we got this down to the fractions are gone. Doesn't that look so much better now that the fractions are gone? Looks way easier, right? So now I've just got to multiply that whole thing out, right? That's no big deal. So p times p plus 2, that's just p squared plus 2p. Now here I'm multiplying 3 things together. So let's multiply those in pairs, right? P minus 2 times p plus 2. That looks like a conjugate pair, doesn't it? A minus b times a plus b is a squared minus b squared, p squared minus 2 squared. I could FOIL it out if I want to, but we can follow that pattern. And then I'll just distribute that 2 to all the blue stuff. And that just gives me 2p squared minus 8, right? So now I can just combine like terms. And let's see, p squared plus 2p squared is 3p squared. I get a 2p. Negative 8 minus 8 is negative 16. Well, look at that. Now I've just got an equation that I could solve, using the quadratic formula if I want to, right? But I got it down to a unit 4 problem, which is no problem for us, right? Plug and chug in the quadratic formula, okay? We don't even need to do that, right? Now we get it down to where we know how to handle it, okay? Let's try another one. How about this guy? Okay, so what do I have to do first? Factor the denominators, good. Okay, so we got to rewrite this guy. If I factor the denominators, I get 1 over x minus 11. That one's prime. Nothing to do there. Next one's already prime, plus 1 over x plus 11 equals 22 over what? What does x squared minus 121 factor into? Yeah, that's the difference of squares. X squared minus 11 squared, right? So I just get x minus 11 times x plus 11. Okay, so what are our, oh, by the way, never mind, it's on this one. It's on this guy. Yeah, never mind. We'll look at this one. Okay, so what values do we have to exclude here? X cannot equal what? Positive or negative 11. Okay, good. Now, what's our LCD going to be this time? Oh, and what's the first factor I need to include? Start. What do you mean 11? X minus 11, yeah. There you go. So x minus 11 gets included from there. And what's the next one that gets included? That one comes from our second fraction. And then look at our third fraction. We've already taken care of those, right? They're already included in our product. So that's it. LCD is just x minus 11 times x plus 11, right? So then all I've got to do is distribute that through my whole equation, right? So I'm going to multiply x minus 11 times x plus 11 divided by 1 times the entire thing. Right? And if I distribute that through, look what do I get in the first denominator then? X minus 11 times x plus 11 divided by x minus 11. So what's going to cancel? There you go. The x minus 11s cancel. Next fraction. How about that guy? Well, I'm going to get same thing in the numerator. What cancels? X plus 11. And then finally, if I distribute all the way over to this last fraction, I get 22 times x minus 11 times x plus 11 divided by my denominator, x minus 11 times x plus 11. And you guys are about to tell me that everything cancels except the 22, right? So then look what happens. We get a simple equation coming out of that. What's left here? The only thing left is x plus 11 plus what's left here? The only thing left is x minus 11 equals the only thing left here is 22, right? Okay, so then let's solve this simple equation. X plus x is 2x. 11 minus 11 cancels. So 2x equals 22. What's our solution? Okay, are we done? How come? Okay, it can't be, can it? How come? Oh, look at that. 11 is disallowed, right? So that one we got to cross out. Now, what if we didn't keep track of that list? We would have just plugged it back into the equation, and where would the universe have exploded where? When I tried to plug it into which fraction? If I'm trying to plug in 11, x equals 11, which fraction is going to make the universe implode? Yeah, that one right there. Look, if I try to plug in x equals 11, look what happens to this guy. That guy is going to become 1 over 0, which we can't do, right? We can't have a 0 on the bottom. That's when, again, the universe explodes. So let's not do that, right? Instead, we're just going to cancel 11, cancel that solution. That was our only one, so what's that mean? No solution. Yeah, the only one we got didn't work. Okay, make sense? Okay, would you guys prefer, I'll give you a choice, because there's a lot of math in one day. Would you prefer, I got one more example to do that I was going to have you do on the boards. Would you rather do it today or tomorrow at the start of class? Is that what you vote for? Okay, let's vote. How many people want to do it today? How many people want to do it tomorrow? How much time we got?
Not enough. Let's just not do it today.
When are we out of here? Is it 20? Yeah. 20? Let's do it tomorrow at the start. That's one thing we got to do tomorrow. You can start the assignment, though. The first half of the assignment are just LCD problems. So you should be fine. You can jump in. I'll make that one live. Yes, you may.